I'll agree, but here we go.
Okay, so this is using Node on the back end, and then on the front end is all vanilla JavaScript with require.js as the dependency handler. Fairly object oriented. There are a couple of places I've cheated just to kind of push it through, but the majority of it is. And rendering, it has got two different canvases. All of the world that you see here is, well actually it's got three canvases. The world that you see here is the world canvas, and all of the players and their names and all the information about them is drawn on the player canvas. However, stored in memory is also a dummy world canvas. And what that does is it's absolutely massive, but it's not drawn. And when it loads, it populates that with all of the different tile information, and then it uses that. What it does is it then copies from that just onto here, so it's a direct pixel copy rather than having to do any actual drawing calculations, which makes it a lot faster. And I lied, there is one more canvas, which is a friction map canvas, and all of the different parts here. If I can log into my GitHub in a minute, I'll show you what some of the friction maps look like. But so on this one, for example, you'll have a light grey here, and then a slightly darker grey here, because it's to have a little bit more friction to slow them down, and then here will be a really dark grey, because that's where it slows down. And there are a couple of different ways I looked at doing that, but because it's quite tile based, it's all kind of 128 by 128 tiles. I decided the best way to do it would be a pixel map, so I will have a drive around quickly and just show you. But yeah, this was inspired by a little game called Micro Machines that I used to love on Mega Drive.
Yeah.
So if I fly around here, and I hope I haven't broken the networking, and I've broken the networking in my last update and I forgot to fix it. But normally, I assure you, you would see Quagmire going around. Just ignore that, the networking is all buggered. This time next month, IGN are going to give it 10 out of 10 at least.
Dude, that is so
That's it, my socket.io half working game. The test of the game, the skill part of the game, is not getting annoyed when it breaks like this the first time you show anyone. But yeah, that's it. I will bring up some of the GitHub if any of you want to have a quick look.
So you wrote all the canvas stuff yourself? You didn't use like D3 or
No,
like
all using raw. In fact, I can show you the front end code just through here. So what we can see here is, so we've got the world canvas and the players canvas. I'll delete the world canvas quickly if I can find the delete button.
Style no,
Suppressor?
visible no.
Yeah, there you go. So I've deleted the world canvas, and as you can see the players are still drawing, still moving around, and if I go here, he's slowed down there because he's now hitting the friction canvas, which is handled in another canvas. However, I had to do two calculations for that, because while the friction all works on the server side, on the client side, because it's all handled through canvas friction maps, there's no canvas on the Node server. So it calculates it in two different ways and just routinely sends updates between the two of the position. So if I take you through a little bit of the code. So I've got the app in here. Vector is just a little vector class. Key handler is just your basic key handler class. Listens for, it's initialized with a scope, which is typically the document or the window. Adds key handlers here and here for key up and key down, and stores it in here, is it true or false, and then you can call the instance. This is a fairly basic prototypal object structure in JS. It's just an object with this constructor and these two public methods. So yeah, Jimmy and Luke, object orientation in JavaScript is nice and easy. Right, it looks really intimidating, but all you do is define a constructor, and then in the prototype you assign it the constructor and put all your methods in there. And because it's JavaScript, you you can just use this dot whatever, and you don't even need to define it, you just whack it in wherever. On to a little bit of the more interesting stuff. We've got animation class here. So you see it defines a world gets a world canvas, and gets a player canvas from the document, and then defines a dummy canvas just in memory. Doesn't actually apply it. Stores them all here, and then what it does is it uses request animation frame, which was written by a very clever person, and it calculates it based on the time between the last draw cycle and the next draw cycle and the average draw cycle time, and draws it so that it's at a fairly constant 58 to 62 FPS. So by doing that, it prevents any lagging between the frames. And so I've got the draw here, which then just calls world animation.draw, player animation.draw. So I'll take over to these. Again, this is split up just to make it a bit cleaner. And then here, that's just accessing the basic canvas. You can see there more of the object-orientedness of it. Draws it all on. This is for the world animation, so it doesn't have much exciting stuff in it. The player animation, even less so, because it just loops through every player and does this.draw player. And then this was probably the hardest bit to master, which was the calculations, because it calculates it all properly based on the friction of the surface under the centre of each wheel. And so if the left hand side of your car is on a surface with a different friction value to the right hand side of your car, the car will move left because of the friction between the two. Then I've got the networking in here. This is all split out, so we've got inbound networking. Good thing about Socket is you can do really nice things with event names. So what I'll do on the server is I will just do socket.emit initialize local player and then send it a little bit of data. And then on the client, I don't need to worry about sending operation codes or anything with it, because it can listen for that string there, and you can assign a different string to any event that you want and go from there. So yeah, you can see I've got just an initialization, a join, a leave and an update. You'll see the join and the update are the same for now. That's just because I didn't want to have one that did both, and it'd be easier to split it into two now and just change the contents when I want to change it. Outbound networking, again, fairly simple. So you can see here, it's sending it off to the server with the message update player and sending off the data, and the server can immediately then tell what it is. So we've got a player object here. This I don't like too much. I'm doing a bit of research on if there's a better way to do it, but what that lets you do is you can pass in JSON into it, and it will then populate itself from the JSON, which is very good when you're sending it backwards and forwards from the server, because otherwise you'd have to manually set every attribute of the object, which isn't ideal. So if I take you here, show you a couple of the assets I've got for it. All free stuff that someone released, which was nice. So you can see here, that's one of the car sprites. It's just got a couple of different colours for the cars and a couple of different models of cars as well. Then onto the tiles. So if I pick, for example, 16, it's tile 16, it's just your standard straight tile used at the top of a straight. And for the friction map for that, if I go to friction maps 16, you can see there it's got the different friction values for each one, which are all read in and passed in, and it's just a grayscale image and looks at the hue. So you've got 255 different friction values that you could have. And there's a couple of other ones you can see there. It lets you do nice complex shapes that aren't very difficult to do, but would be very hard if you were just defining it as paths or something. Whereas you can do it like this, and then you can just overlay the two images and see for any given coordinate what the friction value is underneath it. So yeah, learn Node. It's very fun, very cool.
So all those images were prepared to make this game or something like that?
No, I made the friction maps, but all of the other stuff, the tiles and everything, was just released free by some guy, Creative Commons. So yeah, I just grabbed them. I might stick with them, I might not, but yeah, they were nice. But
Amazing
that's
stuff.
me.
Yeah, man.
Anyone have any questions?
What's your high score, I guess?
My high score, infinite, because I haven't put a lap counter in yet. I did think about putting a lap counter in, but I just thought I want to get the whole game, the basics of the game done first, rather than going down the route of actually making it fun. Because I knew if I went down the route of kind of making it fun and having lap counters and stuff like that, I'd just kind of leave it there and go, this is playable. But as it is now, you can't sit there and play it for any length of time because there's no end game. So,
So can anyone join it now? Can we all just like bring up our laptops and just like?
yeah, if I hadn't broken the networking earlier today, yeah, you would be able to. We do in the office, just sit there.
Really?
And I've had kind of 7-8 people on it, and it all handles fine, real time, and it will only get better really, because at the moment it's because I just made it kind of as a proof of concept thing and built from there, and so it just sends the whole player object backwards and forwards whenever there's any update. So it's optimised a little bit in that if there's no update it won't send anything, but if just they've updated their wheel direction, it will also send the colour of their car, the position of their car. So yeah, just splitting it down. So I reckon with a decent server it would definitely be able to support quite a large number of people.
Cool. What JS server are you using?
DigitalOcean at the moment. I'm just using Node for the server with socket.io backend on the server as well.
Okay.
But
On Express?
I think it is using Express. I chucked the backend together really. I was more interested in how all the front end would work. But yeah, I think it's using Express on the back end to handle the routing and everything.
Cool.
So I didn't understand anything. How does the game work? How do you make to make
the movements and everything.
the movements and all the physics or whatever the name is for games? Are the libraries or you?
Luckily, some poor guy out in America wrote his university physics paper on all the equations needed for car simulation physics.
Okay.
And he then published his paper. So I had all the equations, all the formulas, so I just grabbed them and implemented them. It was quite difficult to get it going, but all the stuff you want, you can find out there. I mean, I could make it really, really extreme if I wanted, just based on, I could take into account suspension, springs and everything. So if I go into here, this is the main kind of game class. And what this does is, so it's got a key detection loop, which isn't really a key detection loop, so that name is lying. It loops through and then checks if any of the keys have been pressed. So you can see here, what this does is it turns the wheel, if they're pressing left, turn the wheel left, right, turn it right, and if they're pressing neither left nor right, then straighten the wheel.
Very clear.
Local car is a vehicle class, so if I take you over to the vehicle class, they're called classes in JavaScript?
Everything's objects.
The thing, the vehicle thing. So then we've got here we've got turn wheel right, turn wheel left, and then we've got this bit to straighten the wheel. Looks quite scary, but just checks if the wheel needs to turn left. If the wheel is already left, then it needs to go right, so turn it right. If it's already right, turn it left. And then that just goes through here, so it just stores the value as a degree. Now, if I take you over...
And that's a CSS rotation, is it?
No, it's all done in Canvas, so it's all drawn through pixel rotations. I will bring that up in a second.
Canvas.
It's really good.
It's like the HTML5 thing.
Yeah. So Whether or not it's going to be adopted much in production environments yet as the canvas, I'm not sure, because a lot of companies obviously don't want to shut off everyone but the latest browsers. But
The canvas element itself is pretty well supported, isn't it?
yeah, but
Quite
I
a
mean,
long time.
back to when you get companies that are supporting IE7 and stuff, no chance.
Well, they shouldn't be allowed.
Okay, so let me talk you through this. It calculates the wheelbase offset, which it gets the wheelbase, it gets the centre of the wheelbase, and then times that by their position of the rotation of the vehicle in radians. And this is to calculate their traction. So it takes into account the current torque output of the engine. At the moment there's just a set torque output, but it would be fairly easy to put into account the torque curve with gearing.
What method is this one? Sorry, I went lost.
Process movement.
Process mode.
So then it gets the constant of the drag coefficient on the floor. So if I take you up to get drag constant, so it takes into account the frontal area of the car in meters squared,
Wow.
the density of the air, which is 1.29
Wow.
kilograms per cubic meter, and
It's doing another version on the moon and everything.
and then it gets the friction coefficient. Now I'm only going to let you glance at this because it's really, really bloody ugly at the moment. So there you go, it looks at the pixel colour and does all the magic. And then it does this equation here. So it times is 0.5, which is a little bit of a magic number, by the friction coefficient, by the frontal area of the car, by the air density, which gets you the drag constant, which means that as you're going faster and you're getting more friction on the ground, the air density will speed up, which isn't the actual way it works in real life, because obviously the air density isn't related to the friction on the ground, but it's a fairly good way of getting the same effect in that you go faster, the air gets thicker. Get rolling resistance. Rolling resistance is just the resistance based on your car actually having to roll forwards, which is typically 30 times the drag constant. Again, that's just a magic number. So if I take you back down to the process movement, so then the drag as a force, all the forces, because the car is always the centre of the screen and only ever moves backwards and forwards, the forces on the car are either forwards or backwards, which makes things very easy because it means that to get the force of the drag on the car, I just get their speed and multiply it by the drag constant, but going backwards. To get the rolling resistance, again, I get their speed and times it by the rolling resistance going backwards. The forwards force is then the traction here, and you can see here how the braking force is taken away from the traction. So the traction plus the drag plus the rolling resistance. Acceleration is then the forwards force of the car divided by the mass. So then you get the speed, and to the speed you add their acceleration, which is a unit over time, and you times that by the time that it's been since the last processing. And then, almost done, you get their the radians of the direction in which their wheels are facing. Now this is the really mathy bit, because there was quite a bit of trigonometry involved in this, because otherwise the way I was doing it at first was kind of like a Space Invaders type thing, where the whole centre of the car turns and it shoots in that direction. But this way, if you turn your wheels slightly that way and you go, it just gently curves the car. So then the front wheel movement is the cosine of the rotation of the car in radians plus the rotation of the wheels in radians, with a y amplifier of the sine of the radians plus the rotation of the wheels in the radians, timed by the scalar of the speed of the car.
I'm out.
And then to the position of the front wheels, which was defined up here as being the position of the centre of the car added to the wheel offset. You add the wheel movement, so that's just finding out how much the front wheels have moved by and getting the new location. For the back wheel movement, you do the same. However, because the steering is on the front wheels, you don't include the wheel radians in these calculations here because it's the back wheels. I did make a couple of mock-ups where you could have like the London taxi steering, So the front wheels turn that way and the backs turn that way, which was really fun but kind of unusable in a game, so I got rid of that. And then you do the same, you add the back movement to the wheels, and then to get their position, you get the front wheels and you add to it the position of the back wheels and you half it. And then to calculate the rotation of the vehicle, you use the ATAN2 function, and I have no idea what that does. And you take away the Y position of the front wheels, you take away the Y position of the back wheels from the Y position of the front wheels, and the X position of the back wheels from the X position of the front wheels, turn it into degrees, and then add 90. So
Wow.
that is how you calculate the movement of the car based on their steering.
You had to ask, didn't you?
Yeah. How does it work?
Yeah, that's what I wanted to know. You know why? Because I love the wheels doing this.
But yeah, any other questions on it?
No, I think it's enough.
So how does it work in terms of like collision detection, for example?
The force, the collision detection between cars, all the forces, because the car is always the centre of the screen and only ever moves backwards and forwards, the forces on the car are either forwards or backwards. All that does is very easy because I can get the
Is it plotting the one canvas against
drag on the car.
where they are? And
If I get their speed and multiply it by the drag constant, but going backwards. To get the rolling resistance, again, I get their speed and times it by the rolling resistance going backwards. The forwards force is then the traction here, and you can see here how the braking force is taken away from the traction. And so when you create a friction traction plus the drag, it creates the rolling resistance, again in memory. It acceleration the dimensions is then the forwards force of the car divided by the mass. So because the tile is one, so then you get the speed, and to the speed you add their acceleration, more canvas setup stuff, a unit over time, and you times that by the time then it's been since the last we get processing this bit, and then almost done. We get their friction tile image, the radians any given of the direction in which their wheels are facing for that. Now this is the really draw it mathy bit because there was a lot of trigonometry involved in this because otherwise the way I was doing it first was kind of and the space invaders type thing where the whole centre of the car directly shoots in that direction. But this way, if you turn your wheels slightly that way and you go, how it's just gently curves the car. This got so canvas front wheel movement, get image data, put in the X and the Y, the cosine of the rotation of the car in radians plus the rotation of the wheels in radians really useful with a Y. It's kind of amplifier of the sine of the radians plus the rotation of the wheels in the radians timed by the scalar of the speed of the car. Really saved me. And then to the position of the front wheels, I knew that the friction I wanted up here from the track as being the position of the centre of the car. I played around with it and kind of got that. Add the wheel movement, and so finding out how much the front wheels are held by and getting some maths degree at work. The back wheel movement came up the same. This here, however, because the steering effectively you put in the colour on the front wheels, which don't include the wheel not actually the colour calculations. But because it's a grayscale image, I did make a couple of mock-ups where you can have like the London taxi steering, so the front wheels turn that way and the backs turn that way, which was really fun, but kind of unusable in a game, so I got rid of that. I think for the dart, and then you do the same. You add the back movement to the wheels, and then to get their position, you get the front wheels, and you add to it the position of the back wheels, and you half it. And then to calculate the rotation of the vehicle, you use the ATAN2 function, and I have no idea what that does. And you take away the Y position of the front wheel, take away the Y position of the back wheels from the Y position of the front wheels, the X position of the colour that they're on, the X position of the front wheels, turn it into degrees, and then add coefficient of that colour.
Wow.
That is how you calculate the movement of the car based on their steering.
You had to ask, didn't you?
Yeah.
How does it work?
So with applause. Yeah, that's what I wanted to do. You know why? Because I love the wheels doing this.
But yeah, any other questions on it?
No, I think it's enough.
So how does it work in terms of like collision detection, for example? How does it know?
The collision detection between cars hasn't been implemented yet.
Okay, or literally collision between elements. So say the car's front wheels and another friction area.
All that does is I can get the friction.
Is it plotting the one canvas against another of where they are? And
effectively, I will just find that for you. Okay, so we've got this friction map class here. And so when you create a friction map, it creates a new canvas, again in memory. It knows the dimensions of the world in width and height, but that's the tile count. And so because the tile is 128 by 128, we do that, which gives us the pixel count.
Yep.
This is all just more canvas setup stuff, as is this. Then when we get to this bit, we can get the friction tile image of any given image that is for that given ID, which is used to draw it. However, what I can do is I can just literally, because it's drawn on a canvas, and I know the position on the canvas directly correlates to their position on the world in the server.
Yep.
Because of how it's drawn, I can just do this dot canvas context dot get image data, put in the X and the Y. I only want 1 pixel, and then I get the first colour from that. So that's something that Canvas is really useful for, this kind of image manipulation stuff, because you can directly get any image data from the canvas for any given point, which really saved me in terms of doing that.
So you literally get in the colour and go, oh right, this is dark grey, I now need to start.
I knew that the friction that I wanted on the track was 0.3. And so
you knew that all along, or?
I played around with it and
okay.
kind of got that. And so, with the help of someone with a maths degree at work, he came up with this here, which effectively you put in the colour, which is not actually the colour, but because it's a grayscale image, the red, the green and the blue are all exactly the same. So it just gets the first colour, which is the red one, and then it's just 1 minus colour divided by 255. So I think for the track colour it's something like 0.17, but I'm not entirely sure.
Yeah.
But yeah, you can.
But just by looking at that, you can then work out what colour you've just driven onto, or where you are at that point, and then work out what to do.
Yeah. So I can just get friction coefficient. I've done a little bit of an update on this that I haven't pushed up to master branch yet, but effectively, yeah, it just gets the colour that they're on, works out the friction coefficient of that colour, and just returns that to be used in the calculations. Cool.
You're having amazing ideas. So good applause.
So anyone?